First of all, very warm welcome to all of you who have taken the time, precious time of 1 hour and attending this session. We really appreciate your motivation and your interest that you have shown in attending this demo session. So today's session we are basically trying to cover one of the topic in Hadoop framework, which is where we are discussing about Hadoop 2.0 features, Hadoop next version features, right? Before I start the actual technical discussions on the topic, let me give you a brief introduction about myself. There are people who are joining it for the first time. So all of you, I am Jaimin Patel. I have over 10 years of software industry experience. I have been developing software for over 10 years. Past 3 years I have got the opportunity to start or get my hands dirty, I would say, in Hadoop framework, Hadoop and big data space. And since then I have been working day in day out in Hadoop and big data technologies. I have been associated with various companies. I provide them consulting help on Hadoop framework, and along with that I also meet with the people who are like-minded, and we do a lot of conferencing in Bangalore across various companies who want to form or share some knowledge on big data and Hadoop. So I have been part of a lot of communities of big data. Apart from that, I also like to interact with people, share the knowledge that I have gained over this 10 years of my experience with the people, and that is one of the reasons why we are meeting here. So I also train people on Hadoop technologies, Hadoop and big data technologies. That's pretty much about myself. We can discuss more about myself, but in the interest of time, I would like to keep it short. We will now get into the actual topic, which is Hadoop 2.0 version. Now here, I just want to make sure that all of us, I hope that all of you are aware of what is Hadoop framework, right? Because when I start discussing about Hadoop 2.0 framework, I'll be also comparing the difference between Hadoop 1.0 and Hadoop 2.0. So if someone doesn't know the basics of Hadoop, I would really, it would be little difficult for those people to understand this. But I'll make sure that you still understand most of the part that I'll be covering, right? Again, it's a demo sessions. We'll just walk you through the high level features of Hadoop 2.0. Let me know if you have any questions. You can always stop me anytime, and I'll be happy to clear your doubts. Okay, so let us start our sessions. Just first walk you through the agenda items. So typically when we want to learn a new technology, we really want to understand that why that technology came into existence. What was the reason why people have developed this, right? Before we start understanding how it works, we need to understand why it was developed. The motivation is the key part if you want to become a good developer in Hadoop. So that is the reason all my sessions which I take up for Hadoop developer training, I always cover motivation first, and then I get into the technical aspects of that particular component. So likewise, Hadoop 2.0, when we discuss, we need to understand why Hadoop 2.0 came into existence. Why industry or people who have worked on Hadoop 2.0 framework, they thought that this is more important than older version of Hadoop. So we will discuss about problems with Hadoop 1.0. Once we understand that, we will get into the Hadoop 2.0 cluster architecture, and we will see what are the differences that it has been that has been made in that cluster. After that, we will get into the YARN architecture. Now YARN is very I know that all of you would have heard about this buzzword YARN, and YARN is a very famous buzzword where people actually want to work on that. So we will cover the architecture of it. We will make sure that high level you all understand what is YARN, how it works, and we will cover LTFS high availability. So today I try to make it at a high level, make sure that you all understand the key differences between Hadoop 2.0 and Hadoop 1.0. So does that sound good? The agenda looks good to all of you? Alright, great. So let us start our journey with Hadoop 2.0 topic. Okay, so Hadoop 1.0 problems. Now, all of you who doesn't know Hadoop 1.0 architecture, there is it's a master slave architecture where you have a master node which is called a name node, and you have many slave nodes which are called data nodes. Okay, the job of a master node is to make sure that where all the data gets distributed in your Hadoop framework. So by the way, in a very quick overview of Hadoop, I can say that Hadoop is a framework which does two important things, which provides functionality for two important things. One is storing a big data in an efficient manner, in a distributed manner. The second thing is, once you are able to store the big data, it allows you to process the data or analyze the data which you have stored on Hadoop framework in a distributed manner. So Hadoop is a framework which gives you two capabilities: storing of the data and processing of the data, processing of the same data or analysis of the same data. That's what Hadoop is. Okay, there is nothing more that you can find with Hadoop. These are the two major problems that it solves, and it solves extremely efficiently, so that it is very widely known and popular across industries for working with big data. Okay, now to talk about Hadoop architecture, since this is a very dedicated class for Hadoop 2.0, so I will not talk much about Hadoop architecture in detail, but I just mention that, as I told you earlier, it's a master slave architecture. You have a master node and you have slave nodes. The master node is called NameNode and the slave nodes are called data node. As I told you, Hadoop stores the data in a distributed manner. So all the data gets distributed. That means if you have a file, for example, let's say if you have a big file and if you want to store it, let's say it's a 1 terabyte file, the file gets divided into multiple chunks and each chunks will get stored on a different node. So I'll just draw a very high level picture here, which will help you understand quickly how Hadoop stores the data. This is 100,000 feet overview, so definitely you need to learn a lot in terms of detail. So if you want to store this particular file, it is divided into 4 parts. Part 1 stores in one of the slave node, 2 is another slave node, 3 is another slave node, and 4 is also stored in separate slave node. This is a master node, these are the slave nodes. This entire thing is called Hadoop cluster. Now when you store a big file into these 4 different parts, you also want to process this file, right? When you want to analyze the data, all this 1 terabyte data which is stored in one file, you have to write something called MapReduce programs. When these programs are written, the master node again distributes these programs into each and every data nodes where your data is stored. It will be distributed in the form of mappers, map 1, map 2, map 3, like that it will be distributed. And finally, once this, so by the way, the MapReduce programs follows divide and conquer strategy. So you first, if you want to solve a bigger problem, you first need to divide that problem into a smaller task, and then you work on this smaller task first. Solve those smaller tasks and then try to merge the output of all these small tasks and then work on the whole. That is how you solve the bigger problem. That is called divide and conquer strategy. Many of your problems in data structures, people used to solve it using this particular strategy. Similar strategy has been applied when you execute a MapReduce program. Hadoop divides your MapReduce program into a small task and let each task work on the individual part of the data which is stored on different data nodes. Once it gets executed on a different basis, it will generate the intermediate output. Let's say output 1 gets stored here, output 2 gets stored here, output 3 gets stored on the third node, like that it will be stored. These are called intermediate output. But we are not, we means the client is not interested in knowing the intermediate output, right? He wants to process this entire data and generate the output. So master node will aggregate all this data, intermediate output data, and send it to, let's say, one of the node where reducer is running. Reducer is nothing but you can assume that it is a process which basically takes this take this aggregated output data from multiple map tasks and work on that to produce the final output, which gets stored on the SDFS or Hadoop distributed file system. So this is how we execute, we basically internally execute our MapReduce programs in Hadoop framework. Okay, so this is just a very high level details about Hadoop framework and how it stores and processes the data. Is it clear with all of you guys? Do you get fair idea about how Hadoop works? We will definitely discuss everything in detail, but right now I hope you got it. Alright, so now once we have this understood, we basically get into the details about the problems that were there in this system. So whatever I have explained as of now, this is about how Hadoop works and how it executes or processes the data. There is one more point that I want to discuss. There is a master node, there is a slave node. Master node will have all the metadata information, slave node will have all the actual data which are stored in there. So when I say metadata information, it's all about, see, when we are dividing this file into multiple parts, all these parts are stored in different data nodes. So these data nodes or slave nodes will just store the parts of the data, but there should be some person or some node who should know how this file is divided. So let's say this file name is f.txt. Okay, so what master node does is it will store an information in this format. f.txt is mapped to part 1, 2, 3, 4. Okay, so these are the block IDs or the part IDs of this file, and also it will remember that part 1 is stored on data node 1 or slave node 1. 2 is stored on data node 2 or slave node 2. Part 3 is stored on data node 3. Okay, so this is how it will remember. This information is called the metadata information, which will be there with the master node. So master node is the only person who knows about this information, and if you want to access the data in your Hadoop cluster, you have to rely on master node, because that is the only person who knows where your data is stored and how do you access your data, which file make up which part, right? Because imagine that there are multiple files of such terabyte size are stored on Hadoop cluster. So every file is divided into blocks, and there is only one person who maintains this mapping, that how many blocks made up a file and where each block are stored in which all data nodes, right? So this information is called metadata information, which is stored with master node, which is called a name node in Hadoop terminology. So now the question is, this is by the way Hadoop 1.0 architecture. So what if this guy goes down? Okay, that is what I am trying to explain. If master node goes down, is there any other way where I can access the data? Because all this metadata information is only with this person. If this person is not available, I don't have any other way to access the data from the Hadoop cluster, and I can safely tell it is as good as entire cluster is down. Do you all agree with me? Alright, okay. So that is why Hadoop 1.0 is called a single point of failure. Okay, that is the major reason why Hadoop 1.0 architecture was called a single point of failure, which means if the name node goes down, you don't have any way to access your cluster, and that means you don't have a high availability. That is one problem. No high availability. There is no backup node. If this node goes down, this node will work as a name node. There was no such functionality available, and you cannot scale like this. So that is why no horizontal scalability and no high availability were the problems in Hadoop 1.0. Right? Now there is another problem with job tracker. Now job tracker is overburdened. So assume that, as I told you, the master node, there is one more, in the master node itself there will be one more process running, which is called job tracker. Okay? So the job tracker, now the horizontal scalability, Bobby, right? The vertical scalability, as if you remember when we discussed, vertical scalability is you are increasing the power of a single machine. So if you have single name node machine, you can still increase, add more RAM, increase more hard disk, add more processing power. So it is still vertically scalable, but you cannot add one more machine and make it as a name node, right? So no horizontal scalability. All right. So basically here what I was telling is, when I explain you this job MapReduce program and how does it get executed in a high level, there is something called job tracker, which is again a master process which runs in this master node, which takes care of executing entire MapReduce framework as a as a master node. So this is the person who is controlling the entire MapReduce job. It is the one who decides that how these tasks are divided into different map tasks and how it will be executed over different nodes. And after they are executed, it will also do the aggregation between intermediate output and send it to one of the reducer node, and then generate the final output. So that entire management of all this MapReduce job will be done by a job tracker. So it was overburdened. Even if I have 100 MapReduce programs which are running on the Hadoop cluster, all these 100 MapReduce programs will be managed by single job tracker available. Right? So that is the reason why we say that it is overburdened. So normally, typically when you store big data on Hadoop cluster, you are talking about dealing with millions and billions of rows or data, and you are talking about terabytes and petabytes of data. So when you want to analyze this data, you will definitely write a lot of MapReduce programs which will run parallelly, and that is the reason why job tracker will be busy serving all the requests. So which was again a problem. It was overburdened. It is the only person who is doing all these jobs, right? And you can, and then one more thing is, in Hadoop framework, Hadoop is a framework which allows you to store the data in a distributed manner, which is good. It allows you to store data in a distributed manner efficiently. That is very good. But now, if I want to analyze those data, do I really need to always work on MapReduce program? Do I need to learn MapReduce programs and always write it in that way? Or Hadoop also provides me other distributed programming technique through which I can write those programs and get it executed on Hadoop framework. So in Hadoop 1.0, it was strictly MapReduce program. There was no other way you can execute or analyze the data on Hadoop framework. And that was also a bottleneck, right? If a developer who doesn't know MapReduce program but he still wants to analyze the data and he knows distributed programming, he would have done distributed programming with some other technologies, but he doesn't know how to write MapReduce program. So that is a limitation for him, and for that he needs to first learn the MapReduce program and then execute that on Hadoop cluster to analyze the data, which should not be the case, and that was another problem. So these are the problems with Hadoop 2.0 that I am talking about. Okay, so if you can see from these pictures, basically it talks about you have only single name node which has the metadata information. So if this node goes down, you don't have any other node who can take up a backup of name node, and that means its entire cluster will be down. So no high availability, no scalability. Let us not worry about the federation part right now. Job tracker overburden. Job tracker is overburden. As I told you, if there are 100 MapReduce programs or 1000 MapReduce programs, all these MapReduce programs will be executed in Hadoop cluster and they will be managed by a single job tracker, allocating the resources, dividing these programs into multiple tasks, constantly monitoring whether these tasks are executed or not. If there is a failure, it will also take care of failure, releasing the resources, resource management. All these stuff are being handled by the single process. Right? There is one more challenge, which was unutilized data in SDFS. As I told you, I can only analyze the data which is stored in SDFS through MapReduce program. There is no other distributed programming support which was there on Hadoop 1.0. Okay, so these are the problems which were there existing with Hadoop 1.0. Okay, so are we all clear with Hadoop 1.0 problems? What are the problems that are there with Hadoop 1.0? So now let me discuss about Hadoop 2.0 cluster. Okay. So now Hadoop 2.0 cluster is basically, as I told you, you have all these problems, and that is the reason why we have added more features to Hadoop 2.0 version which will overcome all the problems. One of the feature is, as I told you, first of all, you always remember this way. Hadoop framework is a framework which allows you to store the data, and once you store the data, it allows you to process the data or analyze the data distributedly. Okay, process the data or analyze the data. Okay, so these are the only two tasks that Hadoop framework does. So even Hadoop 2.0 does the two tasks only, but it has improved the way it does that, or way it supports that. How it has improved? We were talking about NameNode, no high availability. Now it has introduced one more NameNode. So now you have active NameNode and a standby NameNode. So if this guy goes down, you still have a standby NameNode which will work as a backup node on the active NameNode and can start serving the cluster. So both of these NameNode will store the metadata information in a shared folder so that it will be accessible to both of them, so that if one active NameNode goes down, there is still one more backup node available and it can immediately start serving the cluster. So now that NameNode no high availability and horizontal scalability is, that problem is resolved because we have multiple backup of NameNode available in SDFS. Right, so in terms of storage, they have added these functionalities, and that's how they have solved this problem. In terms of processing the data, as we discussed or understood, that job tracker is overburdened. So what they introduce is, they have introduced the next generation MapReduce framework, where they remove the concept of job tracker and task tracker. Now there is no job tracker. They have introduced separate processes for executing your MapReduce job, and I will explain you in detail about yarn in later slides. So basically they have improvised these two big buckets, right, big branches, one related to storage, one is related to analyze or processing of the data, right? Okay. So Hadoop 2.0 new features are, you have high availability of NameNode, you have federation, which means there was only one NameNode and one namespace. Now you have multiple NameNode which has multiple namespace, which has capability to store multiple metadata information, and that is how you can actually distribute the load of storing the metadata information. And we have yarn, which does not depend on job tracker and task tracker. It has better resource management and better application management or MapReduce job execution management. Okay. So if you want to understand high level about the architecture, the way this architecture is layered, you can say that there is a layer called yarn, which is basically, okay, yarn stands for yet another resource negotiator. Okay. And people call it as a next generation Hadoop or next generation MapReduce framework. There is another thing called SDFS2, which is basically an improvement of SDFS. So these are the two main advancements. Over that you have, so now as I told you earlier in Hadoop 1.0, if you want to analyze the data, you have to work or execute MapReduce programs only, right? There was no other way you can do anything else. Here, by introducing YARN, what they allowed you is they provided much more flexibility in terms of analyzing the data. You can write a program in any distributed processing technique. One is definitely the standard MapReduce. All your standard MapReduce programs can still work very well with YARN framework. But apart from that, you can write queries in HBase. You can write queries in Storm. I'm sure you would have heard about this name. It is actually becoming very popular these days. Spark is another in-memory MapReduce framework, which is getting more popularity to process the data in a distributed way. There is a giraffe or graph techniques through which you can process the data in a distributed way. So basically there are multiple ways you can write your distributed programs and still you can execute it on the Hadoop framework using YARN architecture, right? So you don't need to always learn MapReduce programs if you want to analyze data on Hadoop framework. You can still have a lot of other options through which you can write your programs in a distributed manner and you can analyze the data on Hadoop framework. So that is the biggest difference. So now we will talk, we will spend few minutes on YARN and we will understand what are the advancements that are done on YARN. YARN is having a few major components. One is called Resource Manager, Node Manager and Application Master. Okay. So as I told you earlier, your job tracker functionality, which was there in Hadoop 1.0 version, is divided into, it has basically two major tasks: cluster resource management and application lifecycle management. When I say application, it is nothing but a MapReduce program. When you write one MapReduce program, it is called one application. Okay. So in Hadoop 2.0 terminology, all MapReduce programs are called applications. So if you have 10 MapReduce programs running in your Hadoop cluster, you will say there are 10 applications running in your Hadoop cluster. So there is an application lifecycle management is one major task. Another task was the cluster resource management. Both these tasks were being handled by job tracker, but in Hadoop 2.0 in YARN architecture, it is split between these components. Okay. So let us understand that via YARN architecture. So I will actually not get into the too much detail about it, because if you understand the existing MapReduce framework, then it will be a little easier for you to understand this. So I will try to keep it at a high level where all of us can understand it easily. So in YARN architecture, there are few major components. One is called client, who submit the MapReduce job. Then there is a resource manager, there is a node manager, there is an application master and SDFS. Okay. So I'll tell you the role of each and every process. Now here in this particular diagram, there are actually basically this is the architecture of YARN, and this will tell you how a MapReduce program will get executed, or how any distributed programs will get executed in a YARN framework. Okay. By the way, post this diagram there will be slides where I have described about different components which will different basically steps in this job execution. Like you have job submission, job initialization, then you have task assignment, task executions, reporting, and job completion. So all these steps I'm going to explain you just by following this particular diagram. Okay. So let's say we have a MapReduce program that we want to execute on a YARN framework or Hadoop 2.0 framework. Here, first of all, I'll explain you what each of these term means. Okay. So if you draw a Hadoop cluster like this. I'll explain you how does it look like in terms of these terms. So you have a resource manager which is sitting as on a master node. Okay, this is a master node. Now you have all these data nodes or slave nodes where you have node managers running in each of the data nodes. Okay. Once you have this node managers running on each of this data node, so basically the job of this master node is to allocate the global resources to these guys, to the node managers. Once the global resources are allocated, the node managers are managing these resources for that particular machine or a data node locally. So you can say resource manager is a global resource manager, node manager is a local resource manager which just manages the resources in that particular machine. Okay, so these are the functionality of these two processes. There is one more node which is called application master. This is a process. So when, let's say, you write a MapReduce program and when you want to execute it on a YARN framework, when you submit that program, first of all, resource manager will actually allocate the resources. When I say resources, it's like how much memory this program will need, right? How much processing power this program will need. All these resources will be allocated to one of the node manager, and it will tell, now you please take care of creating the application master for this MapReduce program. So it will create an application master. Now as I told you, application master is nothing but if there is 10 MapReduce programs, there will be 10 application masters running. Okay, is equals to 10 application masters. So earlier when I explained you, if there are 100 or 10 MapReduce programs, for example, all these 10 MapReduce programs were handled by one job tracker. Now you have 10 MapReduce program and there are 10 application masters, so that the one person is not overloaded and there will be individuals who are responsible for executing one particular MapReduce program on the Hadoop cluster. Okay. As and when this program completes successfully, the application master will also be closed or shut down and their resources will be released. That entire resource management of this particular application master will be handled by node manager. Now once you create an application master will take care of this MapReduce program and manage the entire life cycle of this MapReduce program. It will create a different map task. As I told you, master will divide that. It's a divide and conquer strategy, remember. So it will divide this entire program into multiple subtasks. All these tasks it will ask them to be created in different nodes, where again there will be a node manager who manages the resources for executing those child tasks. Now these child tasks are called YARN child, and that will be executed in a separate JVM processes, right? So now these application master will basically execute these different child tasks and manages their output. Finally, it gives it to it may give it like this to one of the other node manager where the reducer is running, and that reducer will basically, there is a node manager here and there is a reducer that will process this aggregated output and then finally store it on SDFS. Okay, SDFS. So this is how the job gets processed. It gets successful. The application master sends the status back to the resource manager saying that I have completed my job, it is successful. The resource manager will send it back the response to client, and then everybody is happy, the resources are released. So this is how a MapReduce job gets executed. So initially at a very high level, first step is job submission, where client submit the MapReduce program to Hadoop cluster. When it submits, it will come to resource manager and it will get the new application ID for resource manager. Resource manager, once it returns the control back, the client will save the job related information or MapReduce program related information into SDFS. After that, client's job is over. After that, he will not come into picture. Right? After that step, resource manager will take the responsibility and it will start executing this program. For that, it will first create a resources, allocate that to node manager, who is the local resource manager. Node manager will create a dedicated application master for that MapReduce program, and this dedicated application master will manage the life cycle of the MapReduce programs. It will execute the MapReduce programs in this way. It will basically divide each MapReduce programs into small tasks, let them execute it on different nodes, and then aggregate the output, send it to one of the node where reducer is running, and this is how it processes the entire problem. And after that, it will return the acknowledgement back to the resource manager, and resource manager will tell the final output to the client that your job is successful or not. So this is how the entire MapReduce program gets executed in a yarn architecture. Okay, so did we all follow this? Are we all clear with this? How it works on a high level? Okay, so everyone is fine with that. Appreciate your response. So that's how basically a yarn or MapReduce job gets executed. Okay. So, in a short summarized way, we have covered high level of what are the core key features that are being introduced in Hadoop 2.0, how does it differ from Hadoop 1.0, what was the motivation behind it, how it solved the problems in older versions of Hadoop, and how a yarn architecture works, right? So as I told you, the NameNode high availability, this is how it looks like. You have one active, you have basically only one NameNode and one secondary NameNode. So if this guy goes down, there is no backup node. But in case of Hadoop 2.0, you have active and standby NameNode. So there will be a backup and there will be high availability for that, and it will support the failover as well. Okay. So that's pretty much that I wanted to cover as part of today's demo session. When we get into the actual session, we will cover more in detail about it, and for that, I mean, definitely one needs to know good detail about Hadoop 1.0 architecture so that he can appreciate it better. But I hope I try to give you enough basic details so that you would have got some good information about that. One more time everyone, I hope you like this demo. I'll just spend 5 minutes of your time now to just cover this slide which will talk about WizIQ. So at WizIQ we are doing 2 trainings, Hadoop Big Data Developer Training and Hadoop Admin Training, right? Hadoop Developer Training is rigorous 30 hours online training. On admin training is 24 hours of online training. Now these 30 hours of development training will have a lot of practicals as well as theory sessions. So I can definitely make sure that once you attend this training, you will be comfortable to work with any Hadoop setup or projects with any organization, right? So I have covered most of the topics in detail in this session. In these training sessions where we cover each of the concepts of Hadoop in detail with examples, with practicals, right? Who can attend this training? By the way, anyone who wants to work on big data, analyze the big data, understand the big data architecture is definitely most welcome. Typically database developers, engineers, programmers, Java developers, DBAs, BI developers are the majority of the audience of this class. These are all online classes, they are recorded, it can be accessed for 6 months. That means when you complete your training, even after that the recorded sessions are available, you can refer it for your benefit. You can find more details about this online course at this website. Similar to that, there is a Hadoop admin training, and similar things happen there where you have all the details mentioned in this website. Okay. So that's all about today's session. I hope you have enjoyed this session. If you want to share anything about that, you let me know. I am done with my topic that I wanted to cover. Do you have any comments on that? You please let me know on that. I hope I have made sure that your last 1 hour was not wasted. It was useful to all of you. That was my objective. I hope I have made that objective successful. So nobody is responding. I think everybody is okay. So thank you, Balaji. Appreciate that. So Vijay, typically the Hadoop developer training is for everyone who will be interested in attending the development training or wanting to pursue their careers in development, right? So all big data architects, Hadoop developers, everybody will be attending this training. If someone got trained in admin, then they will attend Hadoop administration training. They will become Hadoop administrator. Oh, so Abhilash is already trained in Hadoop. Thank you, Bobby. Appreciate that. I hope it has given you some revision. So how did you like Abhilash? You have already got trained. Did you like this demo? Was it useful to you? So everyone, please, talk to Sanjeev. He will definitely help you with, all the course details. Yes, he is already responding. Thank you, Sanjeev. So Sanjeev is your contact person. Please get in touch with him. He will share all the course details, the batch details, everything with you. And looking forward to meet you guys in the actual training classes. So thank you so much, guys. One more time, thank you for your time. Appreciate your time and patience. Goodbye to all of you. Thank you, guys.